Anyway, good morning, everybody. I'm Jerry Hovdestad. I think you may have seen me around for a while. I've been now with AirBorn and still dealing with power and now learning about connectors. Been doing this for a little bit over 50 years, and I'm here to give you a bit of an update on power and VITA 62. If anybody's been following VITA 62, I guess we finally released an updated version. I think I talked about it in the Embedded Tech Trends about 2 years ago or so, and a little bit before that they were talking about doing it, and it finally got released. And we set forth trying to get some goals. In VITA 62, we have a 12-volt centric configuration now, which the DoD wanted. They wanted to standardize on that. We added configurations for commonly used versions, things that people have been using for years, 5-volt units, custom units. We defined the mechanical configurations and sort of incorporated all of that into the specification. We have standardized pin assignments to promote interchangeability, and that's a big thing. Is we want to keep power supplies so that they can be built by multiple vendors, and you can interchange them from one manufacturer to another. We added geographic addressing. We picked pins for functions that are being commonly used, like NVMRO, so that everybody puts it on the same pin. And we increased we better defined performance for things like 3.3 aux, and we updated connector part numbers. The connectors have been progressing, and the spec needed to incorporate new part numbers, which it hadn't done. So that was all accomplished, and finally released the spec, and we now have something that can be used, and people are using it. If you've heard, there's a lot of people have given talks, and a lot of them are using VITA 62 power supplies. So here's a little bit of an evolution of the power supplies. In the first spec, which was released in 2012, everybody was talking about 3U power supplies. They had 300 to 500 watt power supplies. And in 6U, 700 to maybe 1,000 watts, and very little intelligence in the power supply because it's mostly dumb. Nobody really incorporated any microprocessors. There was no real standard. They were working on standards, but there was nothing really released. People were thinking about things, and some people had their own special configurations. Some people did a PCI interface and various custom I2C interfaces, but that certainly didn't promote the interchangeability that the government was looking for. You wouldn't want to plug another power supply in and then spend another 6 months or a year reprogramming it to a new configuration. So then we released the version of the spec in 2016, and the power increased a bit, and they started to get system management incorporated in the power supply. That became smart. They get some intelligence. You could do a lot of different things. Power supplies would report errors, tell you what they thought was wrong, and there was some benefit, but the customers were just starting to learn how to use the power supply. They were experimenting themselves to see what kind of benefit they could get from the smart systems. And now we have the 2022 version, and the VITA 4611 Tier 1, 2, 3 requirements have been released, so there is a standard, and the government's been holding plug fests starting in, I guess, 2018, 2019, and the last demonstration was in September of last year rather, and people were demonstrating the capabilities and what they could do with the power supplies. And again, you can see the power has been creeping up. 6U getting people talking about or working on 1,500 watt power supplies, and on the 6U and 800 plus power supplies, depending on derating. They were getting the power up significantly. In the future, they've updated VITA 48.2 for a short VPX, which is a 3U VPX, but only, I think, 100 millimeters, so that it'll fit in a tube. And they're talking about a 4U for future requirements. I'll talk a little bit about that later. And there's improvements going on in the 6U. The one thing they've done, even though they've updated the VITA 48.2 to show a short VPX, nobody considered the power supply. Everybody forgets about power supplies until the end. The mechanical spec was upgraded, but the power supply spec is a different spec. So if systems are coming out using short VPX, they really need to upgrade to incorporate it into the VITA 62 or some other specification because the connectors are different, the mechanical is going to be different, and that really hasn't been done yet. So it's just future work. And the 4U is just being talked about. There's various VITA study groups talking about what's going to be needed to be done to incorporate the new Intel chipsets and the high power levels. And you've heard a lot about everybody talking about the power dissipation requirements. And the 4U is there is no 4U spec, and I'm not even sure it's going to be a 4U, but there's study groups seeing what they need to do to take advantage of the new technology and new systems, trying to figure out where it has to fit and what mechanical features have to be incorporated. And one of the biggest things, and you've heard that a lot in this, is cooling and the power levels that have to be accommodated are way beyond what's being done right now. And there are study groups, and there are a lot of people, as you've heard, thinking about what you need to do about the power. In terms of power supply interchangeability, this slide is about, you have to be very careful. The government wants to be able to buy power supplies from anybody and take a power supply from one manufacturer, plug it into a system, be able to take another one and just interchange it and get all the advantages of these industry standards. However, the specs, even the specs don't control everything. VITA 62, that defines input voltage for a particular requirement. It defines output voltages, regulation, noise, ripple, the mechanical interface, and the basic controls. What it doesn't do is talk about output power. There are some people still doing 300-watt power supplies, and there's some people doing 1,000-watt power supplies in the 3U. And if your system needs 700 watts, a 300-watt power supply is not going to work. So that the system integrator has to look very carefully at the manufacturer's data sheets and make sure that the product that he picks, even though it'll fit in the system, is going to meet his requirements. The EMI, EMC requirements, that's not defined in VITA 62. Everybody's different. Manufacturers, reputable manufacturers, should provide on their data sheets details about what they do, what their conducted emissions are, radiated emissions, susceptibility, and all of those things. And the system integrator, buyer, whatever, whoever's responsible for deciding if it's compatible with a system has to actually take that into account. Same thing with shock, vibration, temperature storage, temperature derating, all of the environmental specifications. The VITA 62 spec does not control those things. It just says it's going to fit and the pins are going to come out in the right place. The ANSI VITA 62 is released. We do define operational mandatory. This is a slide on system management. The spec has been released. It defines all the commands for the power supply. It allows optional commands, so every manufacturer can have features in their power supply that can take advantage of optional commands. One manufacturer may allow a system to actually adjust the voltages in the system or adjust the current limits, and another manufacturer may not. That's not a mandatory command, that's an optional feature. So there are still optional things that are not interchangeable. But if you comply with the formal VITA 4611, at least you'll meet the basic requirements and the basic system requirements. If a system integrator wants to do something different, wants to get a little fancy, he has to work with the individual manufacturer to see if he can use some of the nice features that some people are building into their power. Okay, this is here's a little bit more. I was starting to say on the short VPX and on the 4U or other format. Again, the short VPX is very nice. It allows you to get a lot higher power than small form factor. The VPX supplies can get to 1,000 watts on a 3U, and this small form factor for small applications, you're only talking about maybe 200 watts, maybe something like that, maybe not even. But it hasn't been, no work has been done in terms of the power supply specification to define it. You need to see what people can make, what their pitch is going to be, we know what the height is, it's short VPX, but there's a lot of things that haven't been defined, so there is some work that needs to be done. And the same thing with the 4U, they haven't even decided that 4U is right, but something else is going to be needed to meet the requirements of the future. And again, as you've heard other people say, cooling is going to be a problem. I took this slide, information was provided by, originally Lockheed had this information. Crystal Sumner, Raytheon, has been leading a working group talking about what can be done to cool systems in the future. A lot of the chassis manufacturers are saying, yeah, we need to do something. And right now, you can see, the current capabilities are in the 100 to 200 watt range, depending on the type of cooling. But in that future needs, that information is taken from some of the industry, computing magazines and all of that. They're talking about, now you can cool 100 watts, but you're going to have to maybe cool 500 watts, 2 to 5 years from now. And how are you going to do that really needs to be decided. But there are people, as I said, not necessarily in SOSA, but in VITA, working on that or trying to come up with ways of cooling this so we have things we can use in the future. So again, this is with the power supply. And the power supplies, on the other hand, we see the problem with the computers is you're getting now dissipations, 200, 300, 400, 500 watts. On the power supplies, right now, people are pushing 1,000 watts on the 3U, and maybe you can push that a little further. And there are companies, maybe one working on getting to 6,000 watts on a 6U power supply. And you see the dissipations they're talking about, it can be handled by chassis right now. Nobody's going to make a power supply that the chassis can't cool. So we're pushing the power output, get 2,000 watts out of a 6U supply, and the dissipation is only 150 watts, which people can handle today. How do we get there? Well, you see the efficiencies. The original 6U suppliers were maybe mid-80% efficient. There are companies working on getting to, have achieved 93% on the power supply. So the amount of power you have to dissipate is actually even a little less on this 2,000 watt supply than on the 1,500 watt supply a couple of years ago. So the power supplies are just being produced and being made so they can work in practical systems. And when the cooling comes around to allow them to be cooled, I'm sure the manufacturers can push it further. Some of the new transistor technology and all allows, if you're very careful and do good analysis and good design, you can actually get an awful lot of current out. Previously, the limits on the power supply, the connector was really basically the limit. In some cases, and I had past presentations, the input connector, the input currents were at the limit of the connector, or sometimes it was the output currents. The VITA 62 connectors right now, the spec says they're limited to maybe 40 amps a pin. And depending on what pins you have and what kind of application you have, the connector was really a pretty limiting feature. The connectors have evolved. The original connectors were only 30 microinches of gold. In 2016, people were using 50 microinches, pretty much standard. New specs have come out for high voltage applications with provision for separation and creepage improvements for VITA 62.1 for three-phase AC, for 270 volt DC applications. New connectors have come out. And I just want to mention that the old connectors use multi-beam, TE multi-beam connectors. There are other people doing power supply connectors. And there's now TE's working on has a multi-beam plus, where we were talking about 40 amps per pin. They're talking about capabilities close to 100 amps per pin. I think they're trying to see if they can come up with something that will drop into a VITA 62 supply. And if they can, then we don't need to change the spec, just list the new part number. If not, maybe we need a new spec, but they're trying to decide right now. And if you're interested, I think you can talk to them, and that would, and some of the power lows I'm talking about where we were limited by connector levels, that limit is going to go away. And you had 2,000 watts, maybe you can get a 3,000 watts out of a 6U supply, if you can cool it. And here's a supply that's in development right now, and it has capabilities of 2,000 watts. There are the version in test that can handle three-phase AC with power factor correction. A lot of the systems with AC in the past, you needed actually two cards, one for your input processing, input power factor correction, and the second card, two stages of power to get this. Here on one card, you can get 2,000 watts power factor corrected AC, and 270 volt input or three-phase AC input. Efficiencies are around 93%. And again, currents right now limited by the pins are around 160 amps on 12 volt, and full system management and isolation standard 2100 volts DC. So if you're interested, come and see us. And that's, I think, the end of my presentation. Any questions?